All right, so I'm just going to start at the beginning with these notes in case anyone was absent. But if you were here with me in class, then you can, of course, skip ahead to wherever we left off for your class. All right, so remember exponential functions. Exponential functions have x in the exponent. So you notice all of these have an x in the exponent up here. So that's an exponential function. The first thing to look at is whether it's growth or decay. So growth or decay is going to be based on the base, right? So like the base of the exponent right here. And in the last problem, there's going to be kind of a special trick to that because this negative x right here is going to change things up for us a little bit. So we're going to have to wait on that one a little bit. All right, so in these first two, when the base is a number above 1, then that's going to be a growth problem, okay? Because we're growing, everything's doubling like every minute, every hour, whatever increment you're talking about. Over here on g of x in the middle, 1/5, every time you put a new x in, you get a fifth of what you had before. So say you start off with like 100 bacteria. Well, an hour later, there's a fifth of those left, so 20. And then an hour later, there's a fifth of the 20 left, so 4 left. All right, so that would be decay. So then, of course, you know, when something's growing, you're going to have an increasing function. When something's decaying, you're going to have a decreasing function. All right, now don't write this down yet, but your normal, like if I was just graphing y equals 2 to the x. So let's plug in some numbers. Don't write this down. I'm going to use it to like do the other part. So if I was putting in 0, 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4, 2 to the 3 is 8. So I start getting answers there. If I put in a negative 1, 2 to the negative 1 becomes 1/2. If I put a negative 2, it becomes 1/2 squared, or 1/4. So I get the same answers, but just as a fraction. So what happens is I get this problem coming across here and getting very small, but never touching 0, because 0 is a horizontal asymptote. So whenever you plug numbers into an exponential function, you don't get negative answers. Now, you do get negative answers if it's been transformed, like some of these other problems have, but if you plug it into a basic one, you don't get negatives. So you have a horizontal asymptote of y equals 0. So if you move your problems, so for instance, this right here, this moves you left 3. This moves you right here up 1. Well, up 1 is going to move the asymptote, all right? So like this asymptote that I have right here is going to now raise up 1 level to 1. So this number back here controls the asymptote. So make sure you note that down. This is your horizontal asymptote back here. So my horizontal asymptote in this case is y equals 1. So I'm going to erase this now and go ahead and draw it for real. Okay, so let's draw our asymptote. Our asymptote is at y equals 1. So this is my basic y equals 2 to the x function, but that has been moved to the left 3 and up 1. So remember before I started here. So I have to move that place to the left 3 and up 1. So this is that point right now. It's right there. So I'm going to come through. Left 3, 1, 2, 3, up 1. So there it is. It's going to come down towards the asymptote on this side. Now before I draw the other side, let's go ahead and figure out the y-intercept. The y-intercept is when x equals 0. All right? So if I put a 0 in for my x right here, I would have 2 to the 3rd plus 1. Well, 2 to the 3rd is 8. 8 plus 1 is 9. So I can kind of know that that's right there, and then I'll just finish my problem kind of going up through there. Okay? X-intercept doesn't have 1 because it doesn't touch the x-axis. All right, over to the middle here. And so also notice that this function, it's increasing, so we were right before. It's growing from left to right. All right, so in the middle here, so growth or decay, we got decay because of the 1/5. So this right here, remember, controls our horizontal asymptote. So my horizontal asymptote is going to be y equals -2. So this thing got moved down 2. It didn't get moved left or right, but, so this is down 2. It didn't get moved left or right, but this thing did have a stretch. All right, so let's see. Let's get our y-intercept so we can get like kind of a grounding place for ourselves, 0 for x. So if I plug in 0 right here for x, 1/5 to the 0 power is 1. 4 times 1 is 4, so I get 4 minus 2. So 4 minus 2 is 2. So 2. So 0, 2. Okay. All right. So, because what happened right there is this. Normally, your intercept would be 1, right? So the normal place for a problem to go through when it's a growth or a decay is 0, 1. Well, that answer got multiplied by 4, so this 1 became a 4, and then it got moved down 2 places right there. So that's how we ended up right there. All right, and then it's decaying, so we're going to draw a function that decays and eventually comes down through here. Now, it does have an x-intercept, and I'm not even sure if I put that in the right place there, that x-intercept, but we will do this later. To solve this for y equals 0, it's going to take some logarithms, and we haven't talked about that yet. All right, over here. So this right here, it seems to be a growth problem, because look at that 3 right there. So it seems to be a growth, but it's actually a decay in disguise. So let's see how that is, why that is true. So look at this exponent, negative x plus 1. So it's 3. When you have a negative x, that's a reflection, but it's a reflection over the y-axis. And so let me show you how that'll work. I'm going to pull out a negative 1 from that expression. So if I have negative x plus 1 and I pull out a negative 1, then this would have to become x, and then it had to be a minus 1, because I'm dividing 1 by negative 1 to get my minus 1. So x minus 1. So now I can separate this. I can write this as 3 to the negative 1 and then put the x minus 1 out here, right? Because I'm supposed to be able, when I have exponents like this, I multiply them, and this part multiplies back to this, which that's what I had to begin with. So 3 to the negative 1 is 1/3. So that 3 to the negative 1 really becomes this, 1/3 to the x plus 1. Oops, not plus, sorry, I didn't see that one. Eraser. X minus 1, and then plus 4. So this was really a decay function in disguise, because it was a growth problem that got flipped over the y-axis. So it was, so don't draw this was a growth problem, but somebody flipped it over the y-axis so it looks like that. So it's really a decay problem. All right, so let's just draw it as a decay. Let's see. All right, so this is a decay. It's got moved to the right 1 and up 4. So this 4 back here controls my asymptote. So y equals 4. Okay, so let's draw that asymptote. Y equals 4 up here. All right, and that point that I always go through, 0, 1, it got moved to the right 1 and up 1, 2, 3, 4. So there it is at 1, 5. All right, and let's find our y-intercept. So 0, let's see. So my y-intercept, if I plug in 0 for x, so if I plug in 0 right there for x, I get 1/3 to the negative 1 and then plus 4. Well, 1/3 to the negative 1 flips it over to 3 and then plus 4, so that would be 7. So this is a 7. So 0, 7 is right there, and then I can clearly do my decaying. It doesn't have an x-intercept, so great. All right, so, you know, a couple of these were like a little bit trickier than what you had in Algebra 2, but still the same idea of moving left, right, up or down, and so forth. So let's see what you really got to know here and what you're going to be able to tell me, because before we were just kind of like, just kind of remembering and doing stuff there. All right, so let's see all of our changes here. I have a negative sign, right? That's going to be a reflection over the x-axis. This minus 1, so I'm going to move to the right 1, and this plus 4 moves me up 4. So first of all, know your transformations. Okay, so let's make a graph here. And remember, my horizontal asymptote is the number on the end, so y equals 4. I like to have that on my picture, so let's do that. All right. let's take our coordinate that they all go through. So remember, I'm going to reflect it over the x-axis, go to the right 1, and then up 1, 2, 3, 4. So it should be right here, and it shouldn't really matter what order I do that in. So let me make sure. Let's see. Let's do it in a different order. So let's do this. Let's take our spot. Let's move right 1 and up 1, 2, 3, 4, and then I reflect it over the x-axis. But remember, the x-axis is like this horizontal asymptote right there. So if I take this point right here and flip it over, that's how I also end up there. Okay, so let's see. So this was a growth problem. So normally, if it was still up here, I would have grown, but now it's going to flip over, so I'm going to go like that. Okay, let's find some asymptote or some x and y intercepts before we do that. So the y-intercept, let's check that one out. That's if I plug in 0 for x. So that would be, let's see, -2, 0 minus 1 is -1 plus 4. So that turns into negative, 2 to the -1 is 1/2, and 1/2 plus 4. So that's 3.5. So my y-intercept is 0 and 3.5. So there it is right there. Okay, we talked about how it's going to go. I'm not going to ask you about the x-intercept yet, so just take this and, let's go to Desmos and just kind of make sure it's correct. -2, x minus 1 plus 4. -2, x minus 1 plus 4. Where's my power? There it goes. X minus 1. No. Oh, you know what? You got to put parentheses. Now jump over plus 4. So there's a picture. So let's go ahead and look at the intercept. It's at 3, 0, and there's that other one, 0 and 3.5. So 3, 0. All right, so I don't want to grow it wrong, so there we go. Okay, so domain and range, the domain. The domain is the width. This graph exists everywhere. It goes to the left, it goes to the right, everywhere. So we're going to say all real numbers. The range, though, is not that. It's not the same case. The range, it goes down forever, but it doesn't go up past 4. So it goes -infinity up to 4. It doesn't touch 4. Okay, increasing or decreasing? Well, if you watch this thing from the left, it goes down. So that would be decreasing its whole existence. So it's going to be decreasing from -infinity to infinity. It doesn't increase at all. And behavior, as we go to the right, so as I follow to the right, it goes to -infinity. As I go to the left, it just comes up to 4. So -infinity. And then 4. Okay, and that's all I wanted to go over with you. Maybe read through this little part right here just to remember. We'll talk about it in class, but we will do the rest of this in class, and we'll graph with that and everything and talk about all these like word problems. All right, have a good night.